Very good afternoon, fellow Foundrymen. It gives me immense pleasure in interacting with you all for the 34th webinar or program that is being conducted by the Institute of Indian Foundrymen, Southern Region and Chennai chapter. So this year, under the vibrant chairmanship of Mr. Saktivel Tirunavukarasu, we have been conducting very many webinars and seminars. And one more thing we started this year was management training programs, where we had a tie-up with MMA and we had programs. And now, today, we are stepping into a new initiative where we are having series of webinars. Generally, what we do is we have one speaker coming in, having a webinar, and maybe later on. But we are today starting a series of webinars where we'll be having the speaker talking to us on monthly basis on a topic that is very important. So who better to start it off than very seasoned Foundryman, Mr. S. Sundaresan, Senior Vice President of BrakesIndia Foundry Division. So thank you, sir, for agreeing to take a series of webinars with us. So that is just a small intro. So to get things started, may I now request Mr. S. Muthukumar, Chairman, Southern Region, to welcome the gathering, please.
Yeah, good afternoon. Thank you, Vignesh.
Good afternoon, sir.
Yeah, good afternoon to everyone. I'm delighted to welcome you all on behalf of Southern Region and Chennai chapter to this technical program on zero maintenance and approach. I welcome today's speaker, Mr. S. Sundaresan, sir, Senior Vice President, Operations and Technical from BrakesIndia, Foundry Division, Chennai. It's a great pleasure to have you here, sir, for today's seminar to discuss on zero maintenance approach. This is an important topic that it will help us to improve our operation and increase our efficiency. We are confident that the discussion today will be fruitful and develop better understanding of zero maintenance approach. I look forward to hearing your ideas and insight on this topic. Thank you for taking the time to join us today, sir. Thank you, sir.
Thank you, Mr. Vignesh. Thank you, Mr. Muthukumar, for having. Thanks, IIF, for having given me this opportunity to talk about zero breakdown maintenance approach. In fact, Mr. Shaktivel has been requesting me to share the maintenance, the experience share to all the IIF Foundry fraternity. In fact, so I think this gives a big platform for me to share the basic maintenance techniques. I'm going to start only from a very basic level. Most of you who are participating this webinar, most of you would be at various levels of understanding on the maintenance management. So to have a common basic platform, I start from the very basic so that we could able to nurture and build castles over this basic foundations. And once I complete the program, I would also arrange to provide question answer sessions. And I request all of you to post the questions. And if at all still some of the questions gets unanswered, you may post all this to IIF and then can be further clarified through mail. Okay. So with this short,
we just start. We would like to introduce you, sir. So
yeah, I would just switch on my camera.
Yeah.
So this is me. I suppose that you could able to see me now.
Yes, sir. So we'll just to introduce our speaker for the day. We now request Mr. V.K. Raman, Vice Chairman, Chennai chapter, to introduce our speaker for the day, please.
Yeah, thank you, Vignesh.
Yes, sir.
Am I audible?
Yes, sir. You are audible, sir.
Yes, sir.
Sir, sir. Good afternoon. Good afternoon, sir. How are you, sir?
Very good afternoon to you.
Thank you, sir. Thank you. It is a great and golden opportunity for all of us to witness the presentation to be made by you. Thank you very much, sir. Sundaresan, sir, is a mechanical engineer from the Institute of Engineers, Calcutta, and completed an executive program at Indian Institute of Management, Ahmedabad. He started his career with Binny Limited Engineering Division, Chennai. He has been serving BrakesIndia Private Limited Foundry Division for more than 3 decades in all functional areas. An avid practitioner of total productive maintenance, he spearheaded planned maintenance pillar in approaching towards zero breakdown in Foundry. He is a lead auditor of ISO 14001 and OSHA's 18001 from Bureau Veritas. He is very much interested in learning and teaching and was a principal of BrakesIndia Technical Training Institute for 4 years, besides establishing a course on mechatronics and machine tool maintenance. His other interests include flatly and numismatics. Sir, it is over to you. You can start the presentation, sir. Thank you.
Thank you. Thank you. Thank you for the introduction, sir. So we now start our program.
Sir, when sir is starting, we request all the participants to kindly be on mute because we don't want any disturbance during the program. And also, except the speaker, even I'm going to switch off my camera. So I think all of us can turn it off so that we can have a better experience. Thank you so much, sir. Thanks for the cooperation.
So good afternoon, everybody. I now start with this zero breakdown approach on the maintenance management program. Basically, maintenance management is split into both autonomous maintenance and plant maintenance. When we drive a car, this is a very simple aspect. There used to be always questions. So every one of us, we drive a motorcycle, we drive our cycle, we drive our car, whatever it may be. Once we come across any abnormalities while using our own gadgets, obviously it is our responsibility to see that that gets repaired, that gets replaced, as the case may be. So that means the onus rests with the driver or the owner. So that is all the more important. This shall be the basic with which we approach maintenance management. What I am trying to say is that operations and maintenance are no two different regions. Both are together. So the person who is responsible for the operation is also responsible for the maintenance management. So this is a concept which I am trying to emphasize, rather thrust upon, which makes things much simpler. Because once we talk about any maintenance breakdowns or anything, obviously the person who operates a machine, he shall be responsible. Then obviously he would look in for all the abnormalities which gets emerged during the course of the operations, and he would also get involved in attending to such abnormalities early on time. Thereby the breakdown could be very much eliminated. So this is the concept. So predominantly maintenance objective is to upgrade the to achieve. Basically, we all say that we should have a zero breakdown. So that is most and the first objective of any maintenance management system. Also, we should support the quality maintenance to minimize the defects, to increase the MTBF, which we call it mean time between failures, and to reduce MTTR, mean time to repair. All these jargons we can explain all over the course of the presentation. Everything will be explained in detail so that you will be clear on what you should proceed with. To upgrade the process and equipment knowledge, that is very important. Most of the people who are working with the machines, I'm talking in general, okay, who are working with the machines, they may not know the nuances of the machine first. How this particular mold is made in a molding machine, how metal is really melted in a melting furnace, how we carry out a core shooting happening in a core shooter. So all this we should have a very basic knowledge on the machine management itself. And then we again, when we talk over the other slides, we will also be talking about the entire plant as well, getting broken down into department, and then further getting broken into the equipment, further from equipment to the assembly, and assembly to the spare parts level. So to this extent, we should try to inculcate our knowledge, which we are talking in point number 4. Then to optimize the consumption of the spare parts and minimizing the maintenance cost. Obviously, that is first and foremost. We will also be looking in upon reducing the total maintenance cost, which predominantly in all the foundries you brand under R&D. Okay. So now we are talking about abnormalities. See, machine, once the machine is put into operation, there can be any functional failure or a component failure because of deterioration of the machine. So how does actually the deterioration take place? It can either be a natural and it can also be through a forced deterioration, which predominantly we see both the cases in any foundry industries. Normal saying is that foundry very dark, very difficult to work, dangerous place, and all that people say, dirty and all that. So because of this myth or the terminologies what we talk about, this increases this forced deterioration concept. So how to prevent the deterioration? By operating the machine properly. That is the most important. First, whenever we start operating any equipment, obviously we should have undergone the complete the VDU, the status, how I need to operate the machine, how I get the best mold, how I operate the furnace, how I get the best specific energy consumption, how do I operate properly my core shooting machine, how do I operate my crane, or whatever the machines we operate, we should have a thorough operational knowledge. That is first and foremost. Only then first we could able to operate the machine. Like how I drive my car, that is more important for you to carry out. So that is the first point. Second, by improving the basic conditions. We will discuss what these basic conditions and all that concepts we'll discuss. These some of the terminologies, most of the terminologies I would say they are all from the TPM concepts, which is derived from JIPM, Japanese Institute of Plant Maintenance. So these terminologies may differ from foundry to foundry, but if you have any specific queries over such terminologies, maybe you can note it down and get clarified during the question answer session. Then how to measure deterioration? Normally, I was talking about Jishu-Hosen concept where autonomous maintenance to be carried out by the operator themselves, and then the planned maintenance by the maintenance team. But strictly speaking, there shall not be any maintenance department in any industry. There is no maintenance department. It is only an operation department who should also be carrying out such maintenance activities. When we talk about the initial autonomous maintenance upon the operator level, the measurement of such abnormalities is by senses. So there are 5 senses for all of us provided by the God. So you can able to see the abnormalities, whether there is any oil leakage happening. You can able to touch upon the component. When I say touch upon the component, you should also be careful in not touching upon a rotary equipment or an equipment which is in movement. Okay, so you shall have a knowledge on what I need to touch and what I should not. These things and all will come under maintenance objectives by itself on the teaching educational concepts. So first, an operator may not know how I should open, how I should check. The Sundaresan is talking about 5 senses. He's asking us to check. He's asking us to see the feel, the temperature, and all that. So he should be aware on which area he should need to touch, what he should see, what he should tighten. All such things should be comes under the education and practices through the plant maintenance concepts. And here, so you every day, day out, day in, we are operating near the machine. So once we start standing near the machine and operating the machine, we shall be in a better position to understand whether the noise generated at various points are normal or abnormal. These concepts, we will be the first person to know that there is some abnormality with regard to the noise. Okay, so that is what it means. Then smell. If there is any electrical short circuits, if there is any the coil, if there is any burnt coil in the electrical cabinet, obviously you will be smelling something different. So these are by smelling, by seeing, by hearing, by touching upon all these senses, we could able to understand that something is going wrong with the machine. So this is what without any spanners or without any tools, we could able to see that there is any abnormality in the machine. Then how to rectify this particular abnormalities? The rectification has to come from the reliability. This is an advanced maintenance management system, but once we start from the very basics, we can also get into the reliability maintenance management. Okay, where when I talk about the reliability maintenance, it again addresses on the aircraft maintenance. So the aircraft always the aircraft will be fully occupied. So otherwise you will not get the revenue out of that. Predominantly when the aircraft goes, it again, if you assume aircraft from Delhi to Chennai, immediately upon landing, before the passengers gets cleared and again the newly booked passengers who check in, during this 30 minutes, 40 minutes, 45 minutes, all the checks are to be carried out and the aircraft has to be certified for flying back to Delhi without any problem. Somebody has to sign that sheet. So this talks about the reliability maintenance management. You are assuring that this equipment would function for 6 months without any problem. So that is what it means by reliability. Then we talk about improving the maintainability of the machines. Improving the maintainability, again, I was earlier talking about MTBF, MTTR, that is mean time between failures. If two failures happen, if I normally my operation methodology in my Foundry, I operate 6-day week, 24 hours. Let us assume so. So 6-day week, 24 hours, my machine I had taken up for maintenance management, and then I had did some overhaul and I hand over the machine in the week 1, first day when I hand over the maintenance, when I hand over the machine for the operation. So when there is a breakdown happening within the second week, obviously it had run only for 1 week. So 20 hours of operation, if I take per day on an average, then if it had worked only for 1 week, then 6 multiplied by 20, 120 hours will be the mean time between failures for this particular equipment. So we will also try to understand what are the calculations, which again stands, calculations are again later we can see about that. And in the event a maintenance breakdown happened, let us assume so. So obviously the first act is to look upon the failure and then put the machine back into operation. So if any doctor meets a patient, first he would totally go through all he would ask the patient about various questions, and then once he diagnoses, obviously the first part is to immediately make the patient okay. So that should be the concept. See, maintenance engineers, maintenance technicians, maintenance operators, whatever you name, their first and foremost is to make the machine operable, put the machine back into operation even when there is a breakdown. The first concept, there shall not be any breakdown. The topic itself is zero maintenance. If at all any breakdown comes in, obviously the first aspect is to address the breakdown and put the machine back in operation. So the faster I again make the machine back to work, or I take higher time. So that is what is being determined by mean time between failures, mean time to repair. A machine breaks down morning 7 o'clock, when it is handed over back 9 o'clock. Obviously the mean time to repair is 2 hours for that particular machine. This is how we rectification process. Rectification is the last priority. The prevention and other diagnosis is the most important aspect, which normally we talk about. So the concept of equipment maintenance. Here, let us not go through all the jargons. Maintenance by the production department, maintenance by the maintenance department. These are the two concepts which you should look in. Also, maintenance engaging the outside contractors. There are 3 concepts. In this case, this maintenance engaged by the third contractor, whether there could be some equipment facilities, whether any checking facilities, if it is not available with the specific department, maintenance department, obviously nothing wrong in getting such facilities engaged elsewhere, and then they can make use of the external services. Absolutely, that is not a problem, but nevertheless, the responsibility lies with the maintenance team, even if you engage the external contractors. So when I say maintenance by the production department is the Jishu Hosan, which is autonomous maintenance. I maintain my machine concept. That is called the confidence one operator gives is I maintain, this is my machine. That is a confidence which is derived from the operator who's really operating the machine. That is the autonomous maintenance. And specialized maintenance by the maintenance department is planned maintenance. Okay, so that in Japanese terminology, they call it kaikaku hosen, where it is a planned maintenance, where maintenance department comes in. But nevertheless, even maintenance department works for the planned maintenance activities like a overall, major overall and all that. The operating team also shall be working hand in glove with the maintenance department so that most of the planned maintenance activities which are earmarked at the beginning obviously gets shifted to the autonomous maintenance activities. We need to make a calendar. What are those checks which are being done by the operating team? What are those checks which are being undertaken and then totally executed by specialized maintenance team? I am not using a maintenance department, specialized maintenance, which are also part and parcel of the operational department. Okay, so this is a basic concept with which we approach maintenance management. So I was earlier talking about the doctor-patient concept. Very similar to that, all maintenance engineers, all maintenance technicians are doctors. And I don't want any patients which are craving for the medicine. All the machineries in the foundry shall be as healthy as that of anything like a human, and also they shall be given, they shall be attended any preventive cure, so that which we call it a preventive maintenance at various periodicity, by which always we see healthy machines around. Okay, it is only a health check which is good enough and not a breakdown maintenance. So we are now talking on the same terminology like daily prevention, where we need to have a daily maintenance techniques like lubrication, cleaning the machine, adjustments, and inspection through 5 senses only. So this comes under daily maintenance concepts. Who will be doing this daily maintenance? Obviously, the operator who is responsible for operating the machine, he may have to carry out such daily maintenance like lubrication, like he may have to see this, and he will see whether there is any abnormalities with regard to the noise, he will see whether there is any abnormalities with regard to the smell. He would touch upon and see whether there is any abnormality with regard to the vibrations and all, so on. And also he would do the cleaning. Cleaning is a most important aspect. People might think that cleaning is only to be taken up only when a visitor comes in. Okay, so that is not the concept. We take bath on a daily basis. Similarly, we should be cleaning the machine properly. Only then we can able to see whether there is any abnormalities present. Without cleaning, the abnormalities cannot be visible. There are cases in the machines where even if the machine is kept very clean, the accessibility to see, accessibility to lubricate, accessibility to really see whether there is any adjustment failure and all such things, we may have to make things more accessible. That is on the design front, we should be able to try to improve upon that. That is apart. Regular cleaning itself is very, very important. We shall be cleaning the machine, and initially when the breakdown is going to be the key criteria which needs to be attended in any foundry, because on such case you can even allot some time for cleaning. Because I said that it is not advisable to do the cleaning when the machine is in operation, because it might lead to many safety hazards. So when you take that into consideration, obviously I need to allow some time for the machine to get cleaned. So there could also be a question arising. So when I spend 1 hour, when I spend half an hour, when I spend 15 minutes, whatever the time scale we allot, obviously I lose production for this particular cleaning time. So my productivity is lost. I have planned for 5,000 moles a day. I have planned for 10,000 moles a day. So when I allot this half an hour cleaning, my moles per day gets affected by 300 moles, 200 moles, whatsoever, what on. The question is, it is not, once you start establishing such standards initially, you will see for yourself the productivity will increase. Initially, it might be again a myth for every individual that I waste my time in cleaning. Rather, I lose my production just for the cleaning purpose. I don't waste, rather I lose my production is what the concept with most of the production team. But when you spend this valuable cleaning time, obviously you will come to know many abnormalities during such cleaning. Thereby, you could able to take preventive action during the weekend shutdown, whereby major breakdown could be averted and then improve upon the real productivity of the plant. So this cleaning, it plays a very vital role. And then when I do cleaning, cleaning itself is inspection. I was just telling you, once you start cleaning the equipments, you can able to see the abnormalities. There can be a huge pile-upping of a sand and all that. Only when it gets cleaned, you can able to see whether the foundation board is okay, whether there is no crack on the foundation, whatever it may be, whether there is undue vibration is not there. All such things could be seen only when the area where you need to check is kept very clean. So these are all the activities which are to be taken up on a daily prevention. And the health checks like a diagnosis, we need to carry out the inspection. Again, I will also explain you over the other slides what I mean by the inspections. Then we take upon the early treatment, which you can plan, because while you are doing the cleaning, obviously you will get to know the abnormalities prevailing that particular area, and then you can make the arrangements so that you can also ensure whether such particular abnormalities, whatever that is noticed by you during the process of cleaning, whether that could wait for weekend or that requires immediate attention. So when it requires immediate attention, you may have to inform your superior and arrange for stopping the production and immediately carry out such a rectification, upon which still you can able to solve your MTTR can be much beneficial aspect. Because once you leave that and allow to go for a breakdown, the MTTR will be so high and your loss of production will also be severe. But there is a case where when you see abnormality and you could decide if that could with that abnormality, because you have decided that you have seen the abnormality and your judgment is that it can run for another 3 days, another 4 days until you go for a weekend shutdown. So during which when you could able to attend to this particular abnormality, then you can also plan such things and then carry out the preventive repairs, where you can also plan all the spare parts requirement, all the manpower requirement, or whatever the case. You can do a good planning to carry out such abnormality corrections during the weekend, which we terminate, the terminology of which we call preventive maintenance. You could able to see the screen properly?
Yes, sir. It's very much visible, sir. Yes.
Perfect. Okay. So outline of the maintenance management system. I was talking all along on the autonomous maintenance, which is Jishu-Hosen in the TPM terminology, supporting the autonomous maintenance. So I was telling you initially about education and training. An operator who is operating the machine, he may not be aware what need to be checked, how this should really be, how tight it should be, whether this heat is normal, whether this vibration is normal, whether this smell is normal. All such things you need to teach him. That is very important. Your operator may be coming around the clock, 3 shifts operation. So all those who are involved in such operational practices are to be really taught upon what an abnormality is all about. This is very important. So first is education. I should teach them what is an abnormality, and then they shall be putting up a tag, the color of which you may choose. Individual foundries can choose the tag which are tagged by operational operator. They can be the Jishu-Hosen tags in so and so color. Maybe it is in green color. And if it is a planned maintenance where you require support for the overhaul, where you need expertise maintenance, and also if you require any people from outside contractors should carry out, you may have a different color. But nevertheless, these abnormalities are to be registered in a register and shall be tagged in the machine. That is very important. Then comes preventive maintenance. So once you tag everything, then you need to educate. It is first education is cleaning. Second education is how I should make you understand whether this is an abnormality. And then once this fine. So what are the teachings we said? Initially, they should be taught upon the operational management first, that should be taught on the machine. Second part is that cleaning. What are the areas that needs to be cleaned? so that the inspection can be carried out at those specific areas. Once I do the inspection, obviously I should be aware of what an abnormality is all about in that particular location of the machine. So I should be taught what an abnormality, and then I shall put upon a tag indicating the detail of the abnormality with a date and the person, whatever that you can decide upon. So you need to maintain a chart on the abnormality register, we call that. Abnormality register with the details of abnormality, when it is done and how long will it take to get the rectification done. This is to be documented in a abnormality register. It is very, very important. And there are cases where if the abnormality could be sorted out on the same day itself during the cleaning process or any tundish changeover process or whatever machine, there can be a specific lot where you may be stopping the foundry for a pouring unit changeover, for a mixer cleaning process or whatever. So you may have when you have a regular scheduled stoppages, you may take it during that time and then correct the abnormalities. So obviously in the abnormality register, you shall notify the approximate time, and if at all you do not plan the time for that particular day, you can plan it for the weekend and shall also be clear upon whether this abnormality can sustain until this weekend. So that is what we saw. Then preventive maintenance is inspection, repair, patrol. When I say patrol, again this becomes a GSO's job. Obvious people who are working in, let us assume people who are working in a sand plant. So sand plant is so huge. There are a series of conveyors, there are a series of bucket elevators, series of magnetic separators. There are so many equipments which spread along a larger area. Okay, and mixers, dust collection equipment, so many things. So a person shall be walking around individual equipment and he shall be seeing all this. He shall be noticing the temperature of the motor. He shall be noting the temperature of the bearings. Okay. He will see whether there is any noise in the conveyor rollers. He will be able to see whether there is any shift in the belt conveyor. Okay. All such things can be seen. And then he can put a tag there itself if anything is abnormal. So this comes under inspection and repair. breakdown shall not happen. If at all it happens, the prime idea of any maintenance engineer is to attend to the breakdown first, and then the machine is to be restored, which we call it a failure restoration. Then once the machine is restored, it shall not, the job does not end up there for a maintenance technician. He shall be doing a YY analysis. He shall be doing a PM analysis. PM analysis is a bit exorbitant, phenomenal. That's a physical. That about which we will discuss during the last session. We will talk about the PM analysis a bit, but in general, we shall do a YY analysis. And every one of us might think YY analysis is very easy tool to understand the reason why the failure had happened. If I ask you to do at least 5 whys for the particular failure, when you write down the first, the failure should be written the first. Then if you ask question why this particular motor, the motor is tripped, when I say so, then obviously the first why it is tripped, you will say the motor stopped to run because the shaft is too tight. Okay, then again you may have to put a second why the shaft is too tight. First, you may have to disengage whether the equipment with the motor and try to diagnose whether it is a motor failure or the equipment failure. Then once you diagnose that it is a motor failure, then you may have to put the second why it has failed. Then it is a bearing failure. Then if you put a third why there is a bearing failure, you may not have an answer there. Okay, you may say that the bearing was replaced 2 years ago. It was replaced some 1 month ago, whatever the case. But it shall not end up there. You may have to go, what should be the bearing clearance I should be using, whether it's a C3 clearance, whether it's a C2 clearance, that concept you should go. And fourth front, whether there is any possibility of a dust ingress, okay, which might cause this premature motor bearing failure. Okay, if there is a dust ingress, obviously whether I should go for a sealed bearing and all that. So once you go for at least minimum 5 whys, though you may get some better answer, and then you could able to improve upon the reliability of the system. That's what it talks about, a 5 why, minimum 5 why. But there are cases where you may have to restrict with the 4 whys or so. The more and more why you go in, the more and more the knowledge you gain, the more and more the failure analysis will be visible, not only to you, but to the entire team. And once this particular why analysis is completed, obviously the end of which you arrive at the root cause. So the root cause, once the root cause is known, you may have to take the corrective action. Then once a corrective action, once you say it is a corrective action, first when I say restore the machine, it is called a correction. It is not a corrective action. Restore the machine is correction. That is a breakdown attending and handing over the machine is mere correction. After the correction, I do analysis by which I arrive at the particular root cause of the particular phenomena, breakdown phenomena. The moment the root cause is done and the analysis based on which when you take a corrective action, you shall ensure that this shall not repeat. It might be even due to when the ultimate root cause might also boil down with the design of the equipment by itself. So you may have to have interactions with the equipment manufacturers and try to improve upon the design. Okay, so once you are doing a design improvement yourself, nothing wrong in that, but you shall, it is better that you always have a discussions with the equipment manufacturers in the event of you not getting a definite support from them and all that, you can do it. But nevertheless, you have a detailed analysis by which this improvement, what is being taken up at one particular area of the equipment does not affect the other parameters. So that part of it, you shall have a thorough equipment knowledge and thorough operational excellence, only by which you can able to take the design improvement yourself, by which you can able to prevent this particular recurrence. This is what a breakdown maintenance basically talks about. Once the breakdown happens, you need to restore the machine, and then after one restoration, which is a correction process, you do a complete analysis. Then the end of the analysis, you arrive at the root cause. Then you take the corrective action so that this particular problem does not repeat. This is predominantly the breakdown maintenance. Now we talk about the corrective maintenance. Corrective maintenance is the design weakness correction. I was also talking to you in the breakdown itself. There can be some root causes which might boil down with the equipment design. On such cases, we may have to improve upon the design, which is called a design weakness correction. Maintenance prevention activities, which can be through TBM, which can be through a corrective maintenance, through a reliability centered maintenance. and improve the MTBF and reduce MTTR. That is what is called a corrective maintenance. So these are the predominant maintenance management systems which are to be deployed across any industry, not be necessarily with the foundry industry, be any industry, so that you can really see a benefit of complete equipment availability of the plant in the plant. Then besides these particular maintenance, you need to take care of safety, legal, statutory requirements of the entire plant, spare parts control, which are talking predominantly on the R&M management, budget controls. Of course, lubrication control is not it is superfluous statement here. Lubrication control has to come in the regular preventive maintenance itself. Education and training, about which we already discussed. Okay, so all this data which you derive out of this shall get into a system, and then you shall be in a position to manage through a computerized maintenance management system. Initially, you may have everything through a document, a paper and all that, but over a period of time, you shall graduate into a computerized maintenance management system by which the system should be able to trigger. So these are the checks, and you should be able to enter everything into the system. System should trigger the TBM, system should trigger the CBM, all the data of CBM for the previous data. So you can able to see the trend charts and all that, which will be beneficial for any maintenance engineers. Up to this, is it clear for you?
Yes, sir. Sir, members are replying yes.
Yes, sir.
Members are replying yes.
Yes, sir. Yes, sir.
They could able to hear me properly?
Yeah. Yes, sir.
Okay. So I can continue?
Yes, sir. You can go ahead, sir.
Okay. So we talked about the abnormality first, to understand the abnormality and then taking up the rectification. Okay. This we already we discussed. This particular slide we already discussed. I was talking you about the education. When I say abnormality, so education and training, which uses 5 senses to find out and prevent the cause of 7 types of abnormalities. So we're talking about 7 types of abnormalities. The 5 senses, again, the perception, which is abnormal sound, abnormal temperature, viewpoint, order, so on. And the brain has to do the judgment. Whether I was talking to you in a simpler way, this particular part, I am hearing the noise, whether this noise is normal or abnormal. I am touching upon this particular part. I could able to sense some vibration, whether this vibration normal or abnormal. I am again touching upon a motor cooling fins and say whether this temperature is normal or abnormal. And I am seeing a motor current from the transducer. I see whether the current is normal or abnormal. So based on the kilowatt rating of the motor, obviously there will be a standard no load current and a full load current marked therein. So we can able to see through a system whether my current is normal or abnormal. So like that, we may have to do a judgment. Some of the judgment we can do with a minimum, maximum levels, no load, full load current and all that. Some of the judgment we see. Okay, when we say about Jinshu-Hosen concepts, where an operator does himself, he may not carry any ammeter, he may not carry any vibration meter, he may not carry any noise meter, nothing he'll carry. So he has to do everything with the 5 senses, and with which he reports that there is something abnormal and he puts a tag onto that. Once the specialized maintenance team comes in, they may have to really measure whether this is really abnormal and they take a corrective actions on that. This is a judgment, and based on the judgment, the action is to be executed. And I also told the same statement, cleaning is inspection. We shall clean the machine, which itself forms a part of the inspection. First, inspection is the first step to find out abnormalities. This also we have discussed. And abnormalities should be restored and it should be improved. Improved in the sense, in order to have in the event of where there is inaccessibility, then obviously this particular inaccessibility is to be improved and things to be made more visible. When I say all that, we will see some of the examples which will make you to understand still better. Enhance the ability to find more abnormalities. This is according to supporting to Jinshu-Hosen standard. So we need to do Kaizen is improvement, small improvement. In Japanese they call it a Kaizen. Kaizen to eliminate how to access for cleaning, how to access for inspection, how to access for lubrication, hot axis for retightening, hot axis for adjustment. Okay. So normally CLIR standards that will be displayed. They call it a CLI standards, and some of them will call it a CLIR standards. When I say CLIR, this is what? Cleaning, inspection, lubricant, and retightening. These are the standards which will come in, which will also we see in the forthcoming slides. So these are some of the examples which I am talking to you. When I say initial cleaning and finding out abnormalities, these are some of the equipments related to the foundry, related to the tool room and all that. But you can also put forth in your company, whatever the equipment you are talking about, you can put forth such photographs. Okay. Step 1 is initial cleaning and finding out abnormalities. So this is how the equipment will look like. When I am showing you a disamatic machine, initially when the disamatic, there was no openings available on the doors. Okay. The entire DISA machine was totally closed. So we may not know what is inside. So it is our own interest where we cut open the original DISA door and we provided a glass with rubber beading. What's happening inside? The purpose is that whether there is no abnormalities with regard to rubbing of the hoses because the PP and CP and all continuously will move. There is no abnormalities with regard to the cable, complete cable. It is all the cables. Everything is grouped and it will all be tied across through flexible connectors. So there is no undue rubbing of such things which might cause a breakdown later. So these things can be seen. Also, there are hydraulic systems. We can able to see through the hydraulic systems. There is no oil leakage from the valve blocks or oil leakage from the cylinder gland seals and all that. So we are making things more visible is what I'm trying to say. So this helps the operator even without opening the door can able to see that there is some abnormality. Once he is detecting some abnormality, obviously. Can I proceed?
Yes, sir. Yes, sir. Yes,
Yeah.
sir.
Once we detect such abnormalities, we can put across some tag. I have shown some pink color tag, but not necessarily that people should use the same color and all. You can use your own methodology to just tag the abnormalities. If you see the sand plant, so you have a lot of, in the sand plant, so many conveyors, so many bucket elevators, so many drives will be there. The gearboxes, obviously the gearbox oil level and all, we may have to open the oil level plug and then we may have to see there will be a dip inside. So the dip level people will see and then they say it is okay. For this, you may bring some glass containers or some acrylic container bowls which can be fitted with the gearbox drain plug, and then you can also try to indicate a green red color with which you can able to see the oil level inside the gearbox whether it is okay. So these are the visual controls which by which you can make people to see most of the things. Okay, so this is some of the examples. And second, when you take again I see no abnormality. So once I see abnormality, I need to take some corrective countermeasures to avoid such abnormalities. What are the countermeasures? This is again example. This is again a tool room machine where you have the slots. So you need to have the working area may be limited. The rest of the areas you can use some bars so that the rest of the areas are not entrapped with the machine borings and all that. So there only you are restricting the area of cleaning only to the limited area of use. The rest and all can be blocked. This is just an example. So there can be many avenues by which you can work upon countering these abnormalities. Rerouting the wires, rerouting the cables. It is not wires. It is a panel hoses. I would say this is pertaining to a melting panel. So melting panel has got a lot of cooling hoses. This is not wire again. I correct myself. This hoses, all these hoses are rerouted with a manifold and they are named with temperature sensors fitted for individual loops. Thereby you can able to understand, you can see the flow as well. You can able to name this particular hose, this connected to this particular equipment, this particular ACR or whatever, to the bus or whatever. So with the complete naming, you can able to identify the problem very easily. So this becomes very handy. So this is how you can able to do some countermeasures against such abnormalities. And prevent. Step 3 is the preparation of the tentative standards. When I say tentative, that itself gives you a meaning that it is subject to change. That is what it means. So this is not firm. You are not firmed up at this level because we are starting from a very lowest level by which we educate the people and inform them these are the abnormalities. Then we also teach them how we need to take corrective measures for such things. And also we should try to work in hand with the GSUs and team for making a tentative standard sheets. When I say tentative standards, these are the standards which can be checked by the operator only with the 5 sensors. So wherever this particular hose, wherever the hose is there, you shall mark those hoses. Wherever there's an oil level, this can be marked with a green, red, and wherever there is a bolt, foundation bolt or any equipment bolt, you can make some eye mark onto the bolt and the base, so that there is any shift in the eye mark, we can able to immediately identify that there is a bolt loose. And then pressure gauges, you can mark the range at which this should operate. So these are some of the examples by which all those points of inspection, because these are the areas which require cleaning, because you have identified, okay, these are the areas to be cleaned, and you have identified these are the areas that should be inspected, and you have identified these are the areas where such abnormalities are corrected. So obviously you need to make this particular checklist in such a way covering all those points from maintaining such basic conditions. Okay, when there are no abnormalities on these areas which you had identified, obviously you can say that the machine is in basic conditions. I was telling you basic conditions means when there is no abnormality in terms of no air leakages, there is no oil leakages, there is no water leakages, okay, there is no bolt loosening, there is no pressure drop, all such things when it is exactly in line with the regular operating conditions, you can boldly say the machine is in basic operating conditions. So for you to maintain the basic conditions, you need to have a step 3, thereby you make a tentative standards. Then we go into the step 4. When I say step 4, this is general equipment inspection. I was telling you everyone over a period of years, they should graduate in understanding the machine. The final level is that you shall be in a position to speak with the machine. When I mean to speak with the machine, I mean to speak with the machine. Machine will speak to you and you will also speak with the machine. To that extent, when you go, obviously you are a top maintenance guy. Okay, so when I say equipment inspection, you shall make if you make a general inspection categories, you are categorizing on the mechanical front, fasteners, lubrication, friction materials, power transmission, hydraulics, pneumatics, so any special parts. Okay, then electrical, electronics, so many things you can just mark it here. And then equipment wise, I have marked this few equipments, Mark 5 machine, LP machines, or molding machines. Okay, and then whatever that is applicable, you make those applicability, yes, all that. Once you make all this, then you go, once the fasteners are there, what are those fasteners acceptable for loosening? So that part and all, you need to have an eye mark for that. And what are the lubrication points? You need to have a sticker mentioned, L stickers, all the places. And wherever the accessibility of lubrication is inadequate, you may have to bring the lubrication point in such a way that it is easily accessible. And cleaning, inspection, lubrication, retightening, all such things you may have to bring more visual, like how I explained in the previous slides. And when I say equipment general inspection here, I should also be aware that in the event I do not maintain, what is going to be the consequential effect is what I should be able. Can I just leave to the participants to have any doubts if you have in between? Mr. Vignesh?
Sir, can we just go ahead and take it in the end, sir?
Okay. So I would go. Next step, yes, I would go.
Yes, sir.
Then we'll see. Fine.
Yes, sir.
So now we talk about inspection and repair, patrol maintenance, time-based maintenance, predictive maintenance. We have already explained about these things. So here, this is the maintenance process flow. When I say here, we are talking about inspection, repair, time-based, predictive. Okay. on this front, first let us try to understand. So when we talk about time-based maintenance, okay, time-based maintenance, I need to select a part which is to be replaced, or I need to select a part which can, for which the condition I can check and then make it work for a longer time. So such case, I need to choose this, how I should go about. So a part is selected, okay, then we come across if the service life between 1 overall and the next, if it is guaranteed. Because once I was talking to you as an example, I take up beginning of the first week, I did a overall handing over the machine. If this particular part is okay enough until the next, when I see okay, this is okay, then it goes to the yes, okay. Then the second part, have any causes of forced deterioration been left untreated? Because there can be so much of a forced deterioration. When I say natural deterioration, the component is free from any dirt, is free from any undue heat, it is free from any leakages, it is free from what you call forced deterioration, free from dust, heat, or vibrations. Okay, then you call it a natural. There is a natural wear. Suppose when you have abnormal vibrations, when you have abnormal heat, when you have, because the nearer to this particular equipment, there can be a lot of dust particles flying from the other equipments. So which might end up endangering the life of this particular part. So when it is subjected to such things, obviously this particular part wear out is not by itself by the forced deterioration. So when I say there is a forced deterioration, you need to take corrective actions for such forced deteriorations. When you are taking corrective actions, have all the causes of the forced deterioration be left untreated. So there are cases where I can take the forced deterioration corrections, where there are cases if it is okay. So such case, obviously, I just leave it only with the inspection repair. You understand this point? This is a very important point. For us to decide, should I leave this component only with the inspection repair, or should I take up on a time-based maintenance for the failure, or can I do a condition-based maintenance based on which I take a condition-based and then decide upon the replacement later. So these are the three important decisions which I need to take. That comes under inspection and patrol. Inspection and patrol, once I see this, I need to take the decision. For this decision, I need to go through this. Okay, though this looks like a big chart, but in practice, if you practice this at the machine itself, this will become a simpler job. Suppose the service life between one overall, next overall, it is not guaranteed. I'm not okay with that. Then what I should do? Then I should come whether this particular forced deterioration being left untreated. Yes, it is left untreated. Then you need to go into this. If it is taken care, if you say it's okay, no, then you may have to do the restoration of the particular forced deterioration. See, if it is a dust, obviously you need to put some cover to ensure, at the localized cover, to ensure that the spare part is not affected because of the external dust. So then you do this restoration and improve upon this and come to this stage again. So when you say yes, everything is taken care, obviously this goes into this stream. Okay, is the parts service life acceptable? Okay, so you have taken enough corrective actions, okay, upon the forced deterioration, and you think that the service life is good between one overall to other overall. Then when you pass all these things, when you say the parts life is acceptable, if you say the parts life is acceptable, then you go, is the part service life stable? Okay, this parts is the failure periodicity is acceptable, then it goes into this stage. Okay, then if you say is the part service life is stable in the sense, again there shall not be, suppose some days I see some increase in temperature, then again I do some actions on that, it gets settled. Okay, but you are not replace the part, but you may have to do in between, you may have to do 2-3 corrective actions. So that is what it says. If the service life is also stable, you can directly go for the TBM. So you can assume that this part can be taken up for a time-based maintenance at so and so period, maybe 1 year period, maybe 6 month period. This time-based of terminal, that periodicity of time-based is upon this particular question. Is the service life is acceptable to you? If the service is acceptable, then you name into this part. Okay. And here, if the service life is acceptable, then if the service is not stable, it is not stable, then I go into this. Okay, it is not stable. Then can the deterioration pattern can be identified. I'll have to look in for why this fellow is not stable. Obviously, there is something else, third factor about which I should look in for. So this factor I am looking in. So the deterioration factor if I am identifying, then you need to know what is the parameter by which deterioration can be measured. So these are all the jargons what I speak in this particular slide. The details of which can be seen as an example over the coming slides, where you could able to understand much better. Then if I could able to take a necessary parameter and able to diagnose that these are all the areas the deterioration pattern comes in, then obviously I can take it for a condition based. So I may not run into a risk of a breakdown in between until I sign myself. Oh, this fellow can work for another 1 year. There's no problem. So I signed that particular component. Obviously, you should be clear. Once you sign it, then you are looking into these parts. Okay, you say the service life is okay. You say the deterioration pattern I can identify. You say what are the parameters by which I should control this particular deterioration, by which I can able to diagnose that this particular component come for another 6 months, can come for another 1 year. That's how you decide. Once this particular any of the chain, if you say I could not, obviously you should restrict that point at a TPM. Okay, when all this does not come in, then you should go with the inspection repair. Continuously, you should keep on looking at the inspection repair. Until otherwise I fix all these things, I fix into the step 3, step 4, step 5, then you will continue to remain with the inspection repair. Okay, inspection repair continuously you may have to do. Once you progress on all these fronts, you may live with a TBM, and still you progress onto this, you may come to the CBM practices. Please mind you, TBM is a more expensive maintenance methodology than CBM. CBM, you measure the conditions and then you take a call whether I need to replace or not. And there is a possibility you can extend the life of this particular component based upon your own judgment of the condition based. Whereas TBM, this does not talk about any condition. This says just replace it 6 months, just replace it 8 months, just replace it 1 year. The periodicity of which you fix up yourself, because you say the service life between one overall, other overall is guaranteed, because you say it is yes, because of which obviously you can able to fix up the TBM. CBM is a very good reliability maintenance, centered maintenance is excellent. Then comes CBM. Of course, CBM is a part of the reliability centered maintenance. TBM is the next case where you change it, but still you can prevent breakdown, but this is a bit expensive. IR, you continuously you may have to do. There are a lot of work. You should never leave anything unattended. That's IR. So this is how the inspection patrol, CBM, TBM comes in. I was talking the initial discussions upon inspection and repair. So when I say inspection repair, there are many points. If I say DMM Mark 5 here, this DMM Mark 5 is a diaphragmatic molding machine Mark 5 model. Okay. So when I say check the servo pump belt for the damage and tension, fully alignment, all this there are the categories. This is categorized into PM checks. Okay, because an operator cannot be able to see whether the tension is okay. But if you are bringing in some tension meter, whereas if you just press, if you open the belt guard, you make a slot and you pressurize the belt in such a way that you can able to read something through a scale. This is the tension of the belt. So if you make it so visible, if you make it such gauges to suit your own requirement, obviously these checks can be shifted to autonomous maintenance. Check guide pin dimensions, 20 plus or minus, plus 0, minus 0.1, whatever. So the checks, again an operator, we are using only 5 sensors, I said. Once the 5 sensors checks are done, then we call it an autonomous maintenance. Besides the 5 sensors, if you are using any tool and all that, then it comes under the planned maintenance. So there are cases where all this gauges, gadgets what you use, if you could able to still bring it into the autonomous checklist with a more visual control, then you are making the life of the plant maintenance guy simpler, because everything you are making it more visual. such that all these checks do not require any screw gauge, do not require anything. You can just use a specific go, no go gauge, and then you can say this is okay. So this is how you should be able to share the responsibilities between AM and PM. Please do not forget both AM, PM, they belong to production only. Okay, AM is the person who literally operates. PM is who does a diagnostic analysis and who also helps in repair, but he is also part of the production team. Then comes condition-based maintenance. Condition-based maintenance is a technology that strives to identify the incipient faults before they become very critical, like a temperature maintenance, which enables more accurate planning of the preventive maintenance. When I say condition-based, like temperature checks, okay, like vibration checks, and all such things can come under condition-based maintenance. Okay, this can be either online or it can be offline. Okay, when I say online, it is a complex technical systems where it is involved. We'll also see some of the examples where it is an online. We'll also see some of the examples where it is offline. Offline manual monitoring and tracking is what you call a condition based through offline. So we use BrakesIndia, we use both online system as well as offline system to apply the condition based maintenance management system. So when I say online, this talks about a sensor module, signal processing, condition monitoring, diagnosis module, and present the case. So maybe this jargons look so big. When I come into this, you can see sensor module. These are the transducers which converts the process signal to electrical signals. When I say signal processing, this converts electrical signal to some digital data. Condition monitoring, continuously monitor the data with respect to the time. That's a time stamp data. Then diagnosis module, check whether the data is within the limit or not. Again, limit of which we set ourselves. Okay. If not, activate a corresponding alarm. Say the limit is exceeded, so you act upon that. Presentation, present the complete data trend with respect to time. Okay, and zoom the problematic area. So this is an example. If you take a motor, this is an online. You have a sensor module. What to sense? Obviously, you can sense the current, you can sense the temperature, whatever the case may be. So the transducer, motor transducer, this transducer feeds the signal into a PLC. So the PLC, again, this gives a SCADA, okay, the trend, it will show what is the no load current, what is a full load current. So the diagnostic module will do whether there is a increase, whether there is a decrease. So obviously this will give a trigger, this will give a fault alarm in the mimic panel. Okay, based on the mimic panel fault, people will definitely go and attend whether something is going wrong, because you have a trend completely being monitored with a stamp based trend, and also you have a complete reporting system, the presentation, with which you can able to monitor whether at this particular time where there is a current shoot up, where there is a trip of the motor, and you can able to you will have to do a physical analysis why such a current trip should come. All that, what is the subjective load with the motor when it is connected to the mixing machine, then what should be the load of the mixer, whether there is any undue operations which have taken place. All such things, the diagnostic and all will go later. Okay, so this by which obviously a person who's in the control panel, upon seeing the SCADA, he can be sure that the condition is okay. That's what I'm trying to explain you. Okay, this is online conditioning. When I say offline condition based management, we use very many techniques by which the offline condition based can be practiced. Thermal analysis, which is called thermography, ferrography, the presence of any iron particles in the hydraulic oil system, vibration analysis, because of any foundation bolts not being rigid, because of any crack in the foundation, because of any unbalancing in the rotary system, because of any bearing failure causing undue vibrations or whatsoever, what's on, but we can do the analysis based on the vibration graph, what we get, be it on the velocity graph or be it on the displacement graph. We can able to do the diagnosis whether it is because of what cause. That is what is called analysis. It is not a vibration measurement. First, you start with the vibration measurement, then you may have to get into the vibration analysis, by which you can able to identify that it is because of what phenomena this particular vibration is exceeded. Then shell thickness measurement, with UT sensors, we can do shell thickness measurement, insulation resistance measurement, which obviously every one of us will do, capacitance measurement. Most of the equipment, melting equipments, you will have a lot of capacitor banks connected. So where only upon failure of the capacitor, you will try to replace the capacitor. People may look at the capacitor whether it is bulged. It is a physical analysis by which say capacitor is not bulged. Okay, you may use both thermography as well. You may use a capacitance measurement by which you can decide whether the capacitor requires replacement or not. Then total dissolved solid management. Then gate pulse measurement. These are all gate pulse measurements specific to melting furnaces. Now I'll explain you the individual methodology what we explained, what we saw in the previous slide. Thermal thermography. So temperature monitoring through laser gun. Okay, by which you can see, and you can also maintain a trend graph. This particular point, when I do thermal analysis, I shall be putting across a point in the location where I am seeing it, and this particular point shall be clearly painted so that at the same position, whomever XYZ does this job, he shall be doing at the same position, so that the trend is more meaningful. If he keeps doing at different locations, then the trend may not be so accurate. So by which the number of points what we are doing in BrakesIndia, I have put 350 points, and is what we look in. So you may decide what is a level at which the acceptable range of the temperature is okay, based on which you may say there are so many points you can arrive at equipment wise, and then you can start practicing such things. This comes under thermography. Again, you are using thermal analysis with IR radiance from the surface of the part, where you can able to find out the abnormalities. This is specifically used in high voltage systems, even in HT, where there is any loose connections and all can be seen even when the system is live. That is more important. When system is live, you can able to see the color change, based on which you can call for a shutdown, and then you can immediately attend to this. This is a thermal image analyzer which can be deployed, which are predominantly used for a thermography condition-based monitoring system. On the ferrography, these are hydraulic oil. I was telling you, change the oil filter, change the oil, engine oil, as per the stipulated standard, as suggested by the equipment manufacturer, is what the first statement I did. Over once you gain experience over the equipment, once you start talking with the equipment, you can take a stand that you know what are the various parameters in hydraulic oil, by which the component shall not be put into a forced deterioration, by which there are few parameters which you should look in, like lubricity. There are few parameters which you should really come to know about that. Once you are very clear, then you can do complete filtration system. Okay, this is not a mere filtration. This is electrostatic filtration, by which you have a filter introduced into the system, where it acts as a cathode anode, and by injecting a voltage, the dust particles gets charged. They become ionized. They get charged, and all the dust particles get accumulated onto the filter unit. Thereby, the oil gets filtered by itself. There can also be a mechanical regular filtration system can be used with online filters, but you can use a specialized filtration system also to suit your convenience, by which the oil properties, the basic properties of oil does not get diluted. So to that extent, you need to take care, and then thereby you can improve upon the life of the lubricating oil, where again the used oil that comes under, because you are also responsible for managing the hazardous waste and non-hazardous waste. So these used oil, spent oil comes under hazardous waste category. So by this methodology, you can extend the oil life. Thereby you can extend, you can reduce the generation of the hazardous waste. Then this is vibration analysis. As I told you, this is a measurement. First we do the measurement, and then you restrict for a rotary part of rotating with the 1500 RPM or whatever 1000 RPM. You may have a specific acceptance standard for the pulse measurement, shock pulse measurement, or can be measured in velocity measurement can be done. Okay, or a displacement measurement can be done. Okay, the vibration, normally the vibration is like a spring. If you make a spring tied with a weight, and then if you oscillate the spring goes up and down. Okay, before it comes to its neutral point. So the maximum up, maximum down it goes. If you plot this, then you will get a sinusoidal curve. Okay, once you get a sinusoidal curve, the distance, the displacement is measured between the maximum point to the minimum point. The sinusoidal curve plus the plus side and minus side. So from the neutral, whatever that goes up is called plus. Whatever from the neutral, whatever comes down is called minus. So when you plot like a sinusoidal curve, the top to bottom, when you measure in microns, then that is called a displacement of the particular vibration. And the pitch between one curve to the other curve is what you call it a frequency of the measurement. So the frequency which we will which measure like a velocity, and then the top to bottom measurement in microns is normally termed as a displacement. So there shall be a minimum criteria, acceptance criteria, up to which the displacement can be allowed. So as I was telling you earlier, this vibrations can happen because of the balancing not being proper, because of a foundation bolt getting loosened, because of some crack in the foundation itself, because of some bearing failures or whatsoever. So based on which when you have a periodicity with which when you measure this, and if find either the displacement or the velocity is going out of the range, obviously something is going wrong. So you may have to plan for the weekly shutdown, and you may have to diagnose first. You need to decide whether this equipment would run until the end of the week, upon which you can take some corrective actions. If you decide that this requires immediate attention, obviously you may have to you may have to inform the plant in charge and then stop the production and carry out the corrective maintenance for this. So these are the vibration management techniques. And once there is a when I say the analysis, once the analysis is done, obviously you can take easily corrective actions. So when I say a condition based is an example of which, again the same motor I talk about. So if we do vibration analysis, the trend of the analysis is continuously marked. There is one case where the velocity is higher, and after taking corrective action, the vibration is reduced. Shell thickness measurement. Wherever some of the equipment shells, you may have to measure, you may have to maintain the thickness of the shell for a minimum thickness has to be maintained, for which you can use appropriate methodology. UT can be used, and then you can arrive upon the trending also can be done, based on which the time-based replacement can be really evolved out. These are the conditions by which I can put my signature saying that this can last for the next year until I carry out the next CBM. Then insulation resistance. This is applicable for all the electrical systems, be it a motor, be it a inductor coil or whatever. You can able to measure in megs. Okay, so much of a megger, which is very essential in all the melting system maintenance management systems. Capacitance measurement, I have already explained various capacitor banks connected with the melting system, where people can physically see the capacitor not getting bulged, physically see there is no oozing out of the oil, electrolyte and all that, but you can able to measure. But when you are doing such measurements, you shall be very strong that the system is completely off and it is earthed properly. Then after you may have to take, because without earthing, if you start taking all this capacitor measurement, it might endanger the safety of the personnel as well the property. So you first, before getting into such advanced measurements, you will have to again revisit those first points which I talked about. Know the machine in detail. Then you can get into any sort of activities without, because overconfidence will lead to accidents. But that part of it you shall be very, very careful. Then TDS measurement. Of course, when you take in the water treatment plant, there can be so many measurements which they'll be doing it. pH measurement, TDS measurement, TSS measurement, whatnot. So many things can be done. Total hardness, what is present in the water. Okay, whether dimming water being used, Okay, so when you are using electrical panel, obviously you may use for the cooling purposes, dim in water, either dim in water will be used or distilled water will be used, depending upon the machine manufacturer's recommendations. Coil water shall have a conductivity not beyond so much of micromos. So much of things are to be really documented, and all this comes under the step 3 standards which I explained, where everything is visualized, everything shall be available on a visual note near the equipment itself, so that any person going in, he shall be able to immediately measure and also be able to correlate and make up saying that this is well within the limit, unless he is quite sure what he's doing, and his judgment should also be good enough. Okay, this is predominantly this is water treatment plant, where so much of measurements are being done in a water treatment plant, like I did TDS, pH, TSS, conductivity, so on. Then gauge pulse measurement. This is what we do in BrakesIndia. This is again on the gate pulse in the melting panels. All the melting panel thyristors we connect across and see whether the gate pulse is okay. So we know what is a good and what is bad. So this part, when it is taught, obviously people can understand. But these are the activities which I say the specialized maintenance teams can go and do all this gate pulse measurement. These are some of the offline. I have told you about the online measurement of the condition based, as well the offline measurement. The online measurement, I have explained you what we are doing in online measurement, like a vibration measurement shall be only online, and all these things are offline measurement. Of course, thermal imaging, you will have to do it only when the equipment is live. It is working conditions, you can able to do thermal imaging, thermography, all such things should be done only online. Okay, vibrations should also be done online. Shell measurement, insulation, ferrography, capacity measurement, so many things can be taken upon the condition based maintenance. Okay, so once this is done, you may have other methodology in your Foundry also to add upon the condition based, and equipment wise you may list so much of equipments, and what are those condition based technologies that shall be deployed across those equipments can be marked in this chart. And once this chart gets into a computerized management system, obviously the computerized management system shall have the record in detail and is able to see the trend also as and when needed, and also this can trigger that this is now due for condition based and you can go for that. So such records can be maintained. Okay, so I stop at this point. It is about 4:10, 2 hours. We started at 2:30, right?
Yes, sir. Yes, sir.
I stop at this point. Maybe we continue later, but I leave the floor for questions if any. And if there is further any questions, can directly be sent across to IIF, and I shall be glad enough to send mail clarification to IIF, which I request IIF to spread across to the respective members. Please, floor
Yes,
open
sir.
to the team now.
Thank you, Sundaresan sir, for a very practical, relatable presentation on a very important part, maintenance. The pictorial representation along with your explanation is very commendable, sir. Thanks a lot.
Thank
So,
you.
members, if there are any questions, you may unmute yourself and ask, or you can put it in the chat box.
Hello.
Yes, please.
Hello, sir. First of all, I'm thankful. You have given very good information, and I'm from Kolhapur, Gadge
Okay.
Patil Industries.
Gadge Patil Industries. Okay.
Gadge Patil Industries. And my question is that maintenance computer-based maintenance system. Do you have such a type of system available? Have you made such thing?
Sir, computer-based maintenance comes under the last part, sir. First, you forget about computerized maintenance and all that. There is no computerized maintenance. It is physically people. I said we need to speak with the machine first. Okay. To that extent, I started from the very basics, sir. Computerized maintenance is feeding all this data into your own system. There is no because there are so many software people who can able to make some software and then give you a computerized system wherein upon whatever that you require, they can make such boxes open where you need to enter. Predominantly, you can do it yourself. First, we need to make all this live. Okay, we need to teach the people. We need to do it with hand and then start recording all this. First, you start with the putting abnormality card, which are all not computerized. You need to fit in a card there so that it hits the eye of the operator. Then he corrects that. Then like that, this should be started from this basics. Then all the data what you gather, these data can be fed into a computer. You can have your own systems formed, whereby
Okay.
you can go about that. But there are many people who can make some software and then call with different brand names like a computerized management system and all that. But it is upon us only. Let us not
Okay.
start with the computerized management system today. First, let us start with
Okay.
the very basics and then graduate into that at a later date.
Okay, sir. Okay, thank you.
Right,
Thank
right,
you.
right.
Sir, thank you very much. I am Shanmugam from Madras Engineering. So your today's discussion is very extensive, very useful for the foundry maintenance people. This is the first time I am attending this kind of intensive discussion and this one. Thank you very much, sir. Actually, I want to know the shell measurement thickness you have mentioned, whether it
Yes,
is
sir.
directly we can measure in mm, especially for the Disa-cooled drum and all.
You can measure, sir.
So directly we can, the reading, what you have shown, the model, we can see the cell thickness directly on
Yes, you
mm.
can, because UT, see, UT is extensively used in a foundry, okay? For the casting, there may be a requirement by the customer that you may have to carry out 100% UT for the castings. Okay, to determine any shrinkage defects, internal shrinkage defects. Obviously, or you can have your own quality plan by which every date code I do about 50 per cavity or whatever that you derive upon. So you use UT is a methodology that is extensively used in a foundry. So where you can able to exactly you can say when the casting thickness, the thickness at which you measure the UT, if it is 12 millimeter, 8 millimeter, whatever. So you can able to exactly pinpoint at the 7th millimeter you have an internal defect. Through the UT you can able to determine that. So very similar to that, if a Disa-cooled drum is 16 millimeter, let us assume so.
Yes.
So
Yes.
with the UT measurement, but you need to clean the drum inside. Okay, there shall not be any sand sticking and all. You need to clean the area where you are doing it. And as I said, thermography, where you make a mark exactly the same locations. I measure this particular temperature. So that the trending will be more meaningful. Like that UT also, you make the mark like a UT point number 1, point number 2, point number 3. So many areas you may have in a Disa-cooled drum. So the same point you will have to measure that so that the trending also will be uniform. With from 16 millimeter, you can able to see the trend and then you can decide upon the complete drum replacement over a period of 6 years, 7 years, 8 years as the case may be. You can do it. The question answer is yes.
Thank you very much. One more small this one, sir. So far, we have not heard anything from you about the air consumption and the leakage testing. Whether it will be continued in the next session.
So you are more interested in air leakages.
Sir. So
yeah, that is also one of the major concern in the foundry industry, no?
Okay, I have not included in that, but now I take your point. I will take a specific program on air management control also.
Okay, sir.
The
Thank
next
you very
this thing,
much. Thank you.
air management control, I will take it, no problem.
Okay, sir. Thank you very much. So let the other people ask you some questions. I don't want to block their time. Thank you very much.
Thank you. Sir, there is a
Thank you.
question from, I think, Magna Maintenance.
Hmm.
They have raised their hand.
Yeah,
Sir,
please.
I am in Magna maintenance.
Yeah,
Okay.
My question is condition-based maintenance.
Hmm.
That offline thermography,
Hmm.
how to measure that thermography, or instrument or physically measurement that point?
Sir, instruments, sir. There are two things I explained.
Sir, you tell that HT line.
That is a HT line is it's a camera, thermal camera, thermal imaging camera.
Okay.
See,
How to,
there are see
sir, how to
basically
position that?
the thermal imaging camera is, see, you are using everyone is now clear with using your own cell phone camera, correct? Even a schoolboy, he now uses a cell phone camera and he takes his own selfies and then also takes other pictures, correct? It is very similar to that. You have a thermal imaging camera. You just position the camera at the point where you want to do thermal analysis. So if at all, see, it is like when I go to the slide, you can able to see the difference in temperature. I will just go to the slide again for your this thing.
Okay, sir, I understand that.
Okay, just a moment,
Okay,
please.
sir.
Having asked the
Okay.
question, See thermal, you can able to see the screen here.
Yeah,
Yes, sir.
it's visible, sir.
See, this is a thermal imaging where there are three phases in a contactor. RYB, three phases are there. If you see RY, this is not a physical measurement like so much of degree Celsius. If you see the difference between RY and B is very bright. That means the heat energy at a B phase is much higher when compared to the rest. When you do on a regular basis, you will know that this is normal, and once you see
I am Rajendran. It is Coimbatore, sir.
From where, sir? From which
Mr.
company, sir?
Mr. Rajendran from Coimbatore.
Indoors, Coimbatore.
Indonesia.
Indoors.
Sir, how can we check the hydraulic oil by aerograph?
Sir, basically, I said for the hydraulic oil,
Yes, sir.
normal practice, the supplier would recommend replacement in 1 year or 1.5 years as the case may be. Okay. So
Yes, sir.
initially, when you start your maintenance management system, you just follow whatever the manufacturer says, you please follow. 1 year means you replace it in 1 year. Okay.
Right, sir.
Then,
Okay.
and once you graduate over a period of time, like I was explaining you from the very basics level to a slightly higher level, once you graduate, then you can take a call upon extending this longevity of the hydraulic oil use, for which you use electrostatic filtration or a regular filtration, as the case may be. Okay, that depends upon the purity of the hydraulic oil requirement. Okay, first and foremost, when I say you should prevent forced deterioration, that is first and foremost.
Yes,
I said
sir. Okay.
equipment will definitely be subject to some deterioration. Okay, when I say forced deterioration, if you have access for your hydraulic tank for the entry of the dust ingress from the external environment, that should be the first part from you to stop such external environmental force deterioration. So once you have a basic conditions maintained, then only comes for the improvement with regard to the oil life longevity, where you can use electrostatic filtration, where the filter element will be inserted into the equipment. The equipment has to be in operating mode. This is done online, not offline. So, and then the oil will act as a one charge, and this will be acting, the filter material will be acting as another charge. So this will be subjected to electrostatic charging, by which the presence of the small particles, dust particles or iron particles, which are emerged out from the valve operations or pump operations or whatsoever, they get charged. So once they get charged, their ions, they get attracted towards the filter bag. Okay, then everything gets attracted over a period of time. You can take a sample and with a filter paper, you can pour the sample and see the level of contamination is well within the acceptable range, upon which you can determine the periodicity of the filtration and then the time duration of the filtration also. Once if the oil attains the acceptable quality, you stop the filtration, remove the filter bag, then throw the filter bag out and seal the particular opening of the hydraulic tank, and then thoroughly ensure the gaskets, bolts are properly in place, so that this does not allow further any ingress of the dust into your hydraulic system. So this is one methodology, which is an electrostatic filtration I call. Another methodology, from the tank, you can connect with the pump, which is coupled with the filter elements, series of filter elements, by which mechanically this gets filtered and the filtered oil gets back to the tank. So that you can do multiple times, by which the oil contaminations could be eliminated.
Right, sir. Right, sir. Right, sir. Thank you, sir. Thank you, sir. Understand.
Yeah.
Thank you, sir.
One more gentleman has raised his hand, Mr. Karthikeyan Mahadevan.
Sir, good evening, sir.
Good evening.
Sir, நான் கார்த்திகேயன் குக்சன் இந்தியா அம்பத்தூர்ல இருந்து கால் பண்ணிருக்கேன் சார். சார் எனக்கு ஒரு டவுட் சார். சார் நாங்க வந்து சால்டர் ஒயர் மேனுஃபேக்சரர் சார்.
சார் நீங்க என்ன பண்றீங்க?
குக்சன் இந்தியா அம்பத்தூர் சால்டர் ஒயர் மேனுஃபேக்சரர் சார்.
Wire manufacturers.
Solder wire, soldering wire.
Soldering wire. Okay, got your point. Lead and tin.
Lead and tin, lead free alloy. Yeah. We are manufacturing.
Okay.
Lead free alloy.
Lead free alloy. Perfect.
Okay. சார் என்னோட டவுட் என்னன்னா, சார் நாங்கள் ஹைட்ராலிக் ஆயிலில் வந்து ஆயில் அனலைஸ் பண்ணிட்டு இருக்கோம் சார். இப்போ நாங்கள் சால்டர் ஒயரை வந்து ஹீட்டை ரெடியூஸ் பண்ணுறதுக்கு மோனோப்ரோபைலின் கிளைக்கால்னு ஒரு ஆயில் யூஸ் பண்ணிட்டு இருக்கோம் சார். அந்த ஆயில் நம்ம சிபிஎம்க்கு எடுத்துட்டு வரதுன்னா எதனா பேராமீட்டர் இருக்குங்களா சார்? மோனோப்ரோபைலின் கிளைக்கால் நான் எலக்ட்ரோக்ளீன்ல கேட்டு பார்த்தேன், ஆக்சுவலா எனக்கு கிடைக்கல.
கொஞ்சம் படிக்கணும் நம்ம, அதான் சொல்றேன். We need to read, because the moment you say glycol, then this is a mixer of glycerin and water. கரெக்ட்டுங்களா?
ஆக்சுவலா ஃபுல் கான்சென்ட்ரேட்டட் தான் நாங்க யூஸ் பண்றோம் சார் இங்க.
Oh, you are using glycerin then. It is a glycerin அப்படினா.
மோனோப்ரோபிலைன் கிளைக்கால் ஃபுல்லா வந்து கான்சென்ட்ரேட்டட் எம்பிஜி சார். அது கான்சென்ட்ரேட்டட் வாட்டர் யூஸ் பண்றது இல்ல.
But basically glycerin is one which is fireproof, correctங்களா?
Yes sir.
This is fireproof oil. Glycerin அப்படினாலே this is there will be a water content and glycerin இருக்கும். Okay, you say you don't use water content, but
Yes,
normally with my limited knowledge on this front, because we also used the glycerin based oil in the melting applications earlier, but presently we have gone back to the regular oil. The purpose of using glycerin is that this shall be fire retardant oil. ஓகேங்களா? So in the fire retardant oil the lubricity has to be seen. Of course, lubricity is a factor which is a must for everything. உங்களோடதுல besides the lubricity, viscosity is one factor which has to be very continuously being monitored. Viscosity கூடி போயிடுச்சு அப்படின்னாக்க the flowability oil will be adversely affected. So that is one factor which I can understand. But the rest of the other parameters because we don't use it any further, I may have to go through in detail and I may have to answer you. At present, I'm sorry, I don't have much of a parameter to give my comments.
Thanks sir. Sir, இன்னொரு டவுட் சார். நாங்க பர்னஸ் பாட் யூஸ் பண்ணிட்டு இருக்கோம் சார். அந்த பாட்டோட திக்னஸ் பண்ணாக்கா ஒரு 50 mm இருக்கு சார். அதுல இன்பிட்வீன்ல எங்கன்னா ஒரு இடத்துல லைட்டா லீக்கேஜ் ஆச்சுன்னா கூட பாட்ல லீக் வருது. அது இதுக்கு முன்னாடியே ப்ரிடிக்ட் பண்ற மாதிரி மெக்கானிசம் எதனா இருக்கா சார்? இப்போ அல்ட்ராசோனிக் இல்ல ஸ்கேனிங் இதெல்லாம் பண்ணா காஸ்ட் வைஸ் அதிகமா இருக்கு. கம்மியான காஸ்ட்ல செக் பண்ற மாதிரி எதனா மெக்கானிசம் இருக்குங்களா சார்? ஒரு 50 mm
என்ன மெட்டீரியல் சார்?
கேஸ்ட் அயர்ன் சார்.
கேஸ்ட் அயர்னா?
ஆமாங்க சார்.
கேஸ்ட் அயர்னாக்க நார்மல் ப்ரொசீஜர் UT தான் சீப்பஸ்ட் சார். எக்ஸ்ரே கேன் பி டன், UT கேன் பி டன். நீங்க UT is not expensive நீங்க நினைக்கிற மாதிரி.
ஓகேங்க சார்.
That will be the easiest way by which any shrinkage in the part can be seen through the UT. அதை வச்சுட்டு கண்டுபிடிச்சிடலாம். இது பாட்ல shrinkage இருக்குது, இது லீக் ஆயிடும் அப்படி கண்டுபிடிச்சிடலாம். அது நீங்க நினைக்கிற மாதிரி ரொம்ப எக்ஸ்பென்சிவ் கிடையாது சார் UT.
ஓகே சார். ஓகே, தேங்க்ஸ் சார்.
Thank you.
Sir, we are getting a lot of questions. Sundaresan sir.
I think you may get all this to IIF.
Yeah. I think
4:30 will wind up.
Yeah.
Up to 4:30 I can answer. Then you collect all the questions, send me across through the mail, which I can answer. Okay, yeah.
Right, sir. Sir, Mr. Sudhakaran, you can ask your question, sir.
Sir, good evening, sir. This is Sudhakar from Wipro. So,
good afternoon.
Yeah. So it's a wonderful sessions you are explaining on for achieving the zero breakdowns. So what are all the maintenance we have to done that? It is a wonderful session. So my questions would be on the Q components. You are talking about on the Q components. So can you please have some more brief on the Q components and Q points, sir?
Sir, I will talk about Foundry. Okay, my Foundry. I will take Disamatic molding machine. Okay.
Okay.
In the Disamatic molding machine, when I say Q components, first I would say the pin diameter, pin height of a molding machine. The molding machine has got both swing plate as well as pressure plate. There are two plates on which two halves of the pattern plates are mounted. So the pin positioning of the pin with respect to my reference and diameter of the pin as per the bushes in my tooling. So these are the Q components which we check on a daily basis. Okay, because any deviations in these Q components will endanger the mismatch in the castings. So which will also give rise to unwarranted fins in my castings, leading to undue fettling. Okay, so like a pin, the core sector again, there will be cores generally used, as you know, all Foundry fraternity people, cores extensively being used only where hollow interiors in the castings are required. So the cores are placed into a core setter, automatic core setter. Again, the pins of the core setter, alignment of the core setter with respect to the machine, the pressure plate of the machine, this checks are to be done on a periodical basis, which we do on a weekly basis. Okay, and the movement, and also when we talk about the mold is moved through an AMC, automatic mold conveyor. The mold conveyor will grip the mold every time when the transport is taking place, and it will release when it is coming back. So the gripping and releasing which are happening will be through a thrust bar mechanism. So this freeness of the thrust bar, the gap between the thrust bar, okay, and these things also will become a Q component check, because any misbehavior in the thrust bar mechanism will again endanger, will shift the mold sideways, thereby you will get a side mismatch at the sides. So again, horizontal mismatch we call that. So idu madri, whatever that is, of course, I'm just telling you as an example only. There are so many Q components which we have, but the question is, ungaloda output product, whatever the product you get out through the machines, what are those parameters which can get affected, quality parameters which can get affected because of the machine operations? You are a better judge on that. So when these parameters are because of these machine, and the machine in the particular assembly and the particular component, we should try to brand as a Q components or Q assembly. So these are the minimum criteria at which this should be there. You will have to derive based on your own experience, which you maintain it. If at all machine manufacturers explains this is a tolerance limit, you follow that. If machine manufacturer has not given anything, then you fix up your own tolerance limits, acceptance criteria, by which you have a regular checks. This is what I mean by Q checks. Q checks are applicable for those components which you call as a Q components, which are directly affecting the end product only by the variations of such parts. That's Q period. Ungaloda component ennalla affect aado, you are a better judge for that. As an example, I suppose I made you clear.
Yeah. Thank you very much.
Thank you.
I got it. Thank you.
Yeah.
I think last question, Mr. Shekhar, you had sent a message saying that you want to ask some questions, sir. Okay, so it's not being asked. I think we can move on, sir. So thanks a lot, Sundaresan, sir, for the
Thank you, sir.
patience in answering the questions. So now we will be moving on to the vote of thanks. To deliver the vote of thanks, we now request Mr. D.G. Benakappa, Honorary Secretary, IIF Southern Region, to deliver the vote of thanks, please.
Thank you, Vignesh. Thank you, Sundaresan sir, Senior Vice President, for a nice presentation. Because
Thank
I have
you.
first time maintenance being so preciously presented with all technical information. One time the participation went up to 180.
Correct.
Nice present. I request once again you to come back with the slide in the next. I request you to consider our request. Also, a lot of asking to share the presentation in the group that you can think of. And question and answer session was very lively, sir. A lot of information you shared with us. Thank you very much, sir. Thanks for the nice presentation. And thank you, Chairman, sir, for
Thank you. I will complete the next stage of presentation. Yeah, I will share the presentation after the second session is done. Then I will share the complete presentation to IIF Chennai chapter, and they can free enough to share with any Foundry fraternity team. Not a problem. The knowledge is to be shared. There's no doubt upon that. And this particular air management control system is what was expected from one of the participants, which is not in the part of the presentation. So I will also try to include and talk about the air management system during the next session, so that if that could be beneficial to the particular member who had asked, or for the entire fraternity, it is good. I shall share upon the completion of the program. Okay. But meanwhile, if at all any questions that gets raised from the participants, for the first session. I am glad enough could able to give email reply to IIF on this part. Okay. And thank you for patient participation, because I have been repeatedly talking the same terminology again over 40 slides, but most of which again may be more repetitive. But the intent is that this should get practiced, because this is just like bringing up of a child to a person. So that is how the whole thing which we view. We need to really go along with them, carry the child, and then make the child walk, hand holding, and then make the child walk of its own, then make the child run, then graduates better. So that's how it goes. So most of the things may be more repetitive, but nevertheless, once this gets practiced, I am sure that everybody could able to speak with the machine. So to that extent, the maturity level has to go.
Very nice, sir. Thank you so much, Sundaresan, sir. So we will be meeting in the part 2 of the management series, the maintenance series.
Thank you.
Next Saturday. Yeah, thank you, Sundaresan sir. Once again, thank you.
Thank you, gentlemen, for your patient listening.
Thank you, sir. Thank you very much.
Thank you, Sundaresan.
Thank you.
Yeah, thank you.
Thank you, sir.
Thank you. Thank you.
Thank you very much, sir. All participants, thank you for participation. Hope Chennai chapter to give more such events in the days to come. Thank you, sir. Thank you.
Surely, sir. Thank you.
Bye.
Bye.
Sir.